thanks, Peter, and to the organizers for putting this whole thing together. I'm really loving the event already so much. Looking forward to many of the workshops, and especially to the hackathon. So my name's Eric Bezzam. As he said, that's more fun to say, so that's why I gave him the liberty to say it, so you also have the liberty. So as he said, I'm a tech evangelist at Snips, also working at EPFL, so it's a university in Switzerland. And also, I'm a founder and organizer of Hackathon, and I heard there's a hackathon at this event. So I'm really looking forward to interacting with you guys. So who's here for the hackathon, actually, so I can get in? Oh, they already started? Okay, so I'll go see them later on then. Yeah, really love hackathon, so that's a really cool initiative. So I guess what I want to start to talk with is just telling you about one of the first applications we saw of voice assistants, which was back in the 1950s, where computers were just in their early stage. And there was this laboratory, Bell Labs, in the US, very well known for their research in communications and telephones, who was looking into a system that could recognize spoken digits. So just speaking 0, 1, 2, 9. And I'll just leave you that story for now, and we'll come back to this later on to really figure out what was their main motivation, because I think this is a very interesting story. But how did we get to voice assistants in general? So as we talked about, there was 3 main pillars that brought us to this stage. So one of them was the algorithms behind it, which really, we hear a lot about deep learning and machine learning at the moment, but a lot of the algorithms that we are talking about came up in the 50s, 60s, 80s, and it was only that in the very recent years where we had the available hardware and the data, thanks mainly to the internet, which allowed us to get to voice assistants. And it was really this big competition called ImageNet, which made this huge topic of deep learning and CNNs, if you guys are familiar with it, really mainstream. And then Google, Microsoft, Apple started hiring a bunch of engineers and researchers in this domain to build different solutions, one of them being voice assistants. So this is the general voice assistant pipeline that we see in many solutions, including ours at Snips. It first starts off with a wake word detector, so saying, hey, Snips, OK, Google, Alexa. And then after that comes all the intelligence part of it. I'll leave that part of it for the workshop that I'll be giving later today. But the one main distinction that I wanted to talk about today was this idea of cloud versus on-device computing. And this is really what sets us apart at Snips. Because a lot of the main solutions, at least the consumer products that you hear about, such as from Google, Siri, Amazon, what they rely on is a server far, far away with immense computing power in order to handle all of your requests for a voice assistant. So what they're trying to build is a general assistant which can handle any of your queries. And once the wake word is detected, so whichever it may be, they would stream all of your voice data to their servers to perform the necessary natural language understanding to then fulfill your request. And from a study in 2017, these are some of the main examples that we saw of what users wanted. So it was either performing an online search, asking a funny question, just playing some music, or weather forecast. And what we were really trying to see in Snips is it absolutely necessary to send your voice data in order to fill these requests? Sure, you need internet, to connect to any music services or weather, but why can't all that understanding be done on the device rather than sending all of your voice data to the cloud? Because one thing that is really fundamental to your identity is your voice. And I'm not sure if any of you have heard of this startup in Canada called Lyrebird. Who's heard of this one? So a quite creepy technology. So with 1 minute of audio, obviously you need to provide specific recordings. They can recreate your voice. And combined with data that is stored on servers where we don't know, if this gets into the hand of malicious people, who knows what could happen and what effects this could have on our society. So this is something I really want you guys to keep in mind, that is it really necessary to give our data, whether it be for voice or in other applications? Because when that's given away, who knows what could happen if there's any data breach. So at Snips, as I said, we focus completely on device, and our approach is to rethink the solution to assistance. So instead of creating this general voice UI that can handle any of your crazy requests and commands, we create very specialized models. And due to this, they're able to fit on the device itself and actually require less data for training. And what's also important is that we benchmark our solutions to show that you can trust them in terms of their performance, not just in terms of your privacy. So we have a bunch of benchmarks which you can check out on our GitHub and also various Medium articles. I think the most interesting one is one that came out a couple days ago where we did a test on understanding users' requests for an artist and a song, because here you have a very varied, wow, that's quite alliteration. Very varied set of username of artists and songs, so that could really throw off such a system. And we showed that we're really on par with Google's solution when it comes to this task. And another thing that Peter talked about is being open. So all of our NLU libraries are open and easy to use and free to use on Python, on Rust, and also on the console, which we'll be going through in our workshop. And we also plan to release all of the other components, so which we saw earlier for the acoustic speech recognition, so taking your speech and putting it into text. And just all of our libraries will soon be open source. But for now, we've started with the NLU library. So coming back to this example here about AUDREY. So I said it was a solution developed at Bell Labs. And I guess one question I want to see with you is, what would you think was their main motivation in building such a system, being a telephone company, how to recognize digits? Any audience participation? Yes? Okay. Anything else? It's maybe a simpler solution. Yeah. For dialing a number. Yeah. So it is for dialing a number, perhaps. Yeah. To make a call. So in order to make a call with the voice, what they were trying to do was, something along these lines, is that they wanted to reduce the data bandwidth. And instead of sending pure audio file, if they could just send the digits themselves that were recognized, that would obviously be much less data to transmit over the communication lines. So they had this very engineering motivation behind this. And perhaps we don't have the same motivation because now we have unlimited data bandwidth and unlimited processing. But just because these algorithms are data hungry doesn't mean they need to be data greedy. So that's one approach that we think is very important at Snips. We apply it to voice assistants, but it's something which hopefully can inspire others to create private by design solutions and which are trustworthy and fit along this Trustmark brand that we are very excited to be a part of. So thank you very much for your attention. If you're interested, do come to our workshop at 10:45. We'll be doing a very hands-on workshop on how you can build such a voice assistant. I don't know if we're still on time. Oh, it's probably still possible. And we'll also be giving a free maker kit. So join us, and it should be lots of fun.
Awesome. Thank you.
Yeah, thank you. Just like stay on for just like 2 or 3 follow-up questions.
Yeah, sure.
Because I was like so amazed when I first heard about Snips. I was like, I was like, it can't work, impossible. What were some of the design decisions that you like? How did you what was your motivation initially to say like, okay, we're gonna go the harder way and like do a different route there than all the cloud-based voice systems? I mean, you touched on it before, but
I think it's similar to the idea of the Trustmark. I mean, as engineers, we really want to make it clear what our product is doing, and and the consumers, maybe they're not aware of it, but once they're aware of it, they'll know that this is a very important thing to be part of your life. I mean, if technology is going to be ever so prevalent in our lives, we don't want it to be intruding our privacy. So,
yeah, that's really amazing. Is there any, I think we should take maybe 2 questions from the audience, because we're still just on time. Yes?
What's the minimum hardware requirement for the edge voice recognition?
So at the moment, our reference design and what we'll be doing on the workshop is on a Raspberry Pi, so quite standard, not too demanding, so quite accessible.
What is the biggest struggle that you had to overcome?
The biggest trouble I had to overcome? I think what's very important whenever you're doing any type of machine learning is to be very meticulous in how you design your approaches and also setting the proper benchmarks. So once you've done that, it really eases the whole process. So it's being very meticulous about it. So perhaps maybe we come up with a solution which may not necessarily fit on the device, but from there cutting it down so that you can get to what you need.
Yeah. Marcel, last question.
What's your roadmap towards understanding Scottish people?
Scottish people. That reminds me of, have you seen this video about 11 when the guys are talking? Okay, I think
we can loan you a Scottish professor who's one of our partners.
Yeah, so I mean, so that requires, I think we have a position open for linguist engineers, so that is something we need to first hire someone and then they'll help us with this type of solution.
No, it does work, it's charm. Yeah. I've tested it, it's amazing. Thank you so much, Eric. You'll be on stage later. Thanks so much for being here, but also for being one of the test companies for the Trustmark. Back to Monique.
Just. Thank you both. Thank you both.